Okay, so just like what we did when we had confidence intervals, when we had the population standard deviation, we could calculate a sample size. We can still do that with proportions. I know this looks nasty, but it's pretty easy. Okay, remember, small n is my sample size. This right here has to do with your z-scores. This is the proportion of success. This is the proportion of not success. And here is your error bound of proportion squared. So let's do this. Suppose a mobile phone company wants to determine the current percentage of customers age 50 plus who use text messaging on their phone. How many people age 50 plus should the company survey in order to be 90% confident that the estimated sample proportion is within 3 percentage points of the true population of customers age 50 plus to use their text messaging? Okay. A lot of times in research, we want to know if we have the correct sample size. There are calculators out there to do that for you. They are kind of tricky, so this might be the better way to do that. All right. So here it said, I'm going to do this. Let me push it here so it might be easier so you can see what I'm doing, so I can highlight stuff so you see where I'm getting it. All right. So what's important? So this right here is important, this 3 percentage points. And then right here, my 90% confidence. Okay. Those are very, very important. So I know my error bound proportion is 0.03. It's the same as that 3 percentage points because I want it to be within 3 percentage points on there. And then the z with the alpha divided by 2 is 1.645. And that's because the confidence level is 90%. That's where I got all that stuff. Remember, if I go back to the beginning of this PowerPoint, if I look at 0.90, here it is 1.645. So that should be able to help you with that. Okay. All right. So let's keep going. All right. So, all right, I've got that. So then I know those items. Then all I need to do is I just need to plug in. All right. Since it didn't give us how many so it didn't give us our trials or our numbers. It didn't say, oh, I know 500 seniors out of 700 text message. It didn't give me that. It didn't give me it at all. So because of that, I'm going to use the default, which is 50%. So it's kind of like chance. It's like tossing a coin. You got a 50% chance to get heads, 50% to get tails. So the same thing with this. It's not always the case. If you're given your sample with the number of successes, you always use that. But in this case, when you're not, you don't have to. So 1.645 squared and a 0.50 times 0.50 and then divided by 0.3 squared gives me 751.7. I always round up because it's always okay to have a bigger sample size. So 752 cell phone customers age 50 in order to be confident. All right, let's do something else. What if I did this? I'm going to do another quick sample. I'm going to copy this thing, duplicate. Okay. I'm going to go here and I'm going to call this B. All right. So let's say this. Say I know that, let's do 65% of customers aged 50 plus may text message. Okay. So I was given that, correct? 0.65. All right, so let me do this. I'm going to duplicate this slide too, and I'm going to push it down here. All right, so things have changed a little bit. All right, so now because I know that 65% right here, remember I just said this, 65%, I'm going to highlight it in yellow. Okay, so now P at equals 0.65 and the Q equals 1 minus 0.65, which equals 0.35. Okay, so I've changed it slightly, but it's not a big deal. So if I go here, then this one is going to be 0.65, and this is going to be 0.35. All right, so look what I'm going to do. I kind of did this for a reason. I'm going to put this stupid thing in my calculator. All right. My best advice, do it in steps. So I'm going to do, if you have one of these, it's okay. If not, just do it in steps and it won't be bad. All right. Okay, so if you can see, I'm doing this top row first. Oops, not good. Okay, times. And you're like, why are you using all these parentheses? Remember, order of operations, it does matter. Okay, so I'm going to do the top first. Okay, and then I'm going to divide it by my bottom. 0.03 squared. Okay, enter. Okay, so now it changed. It says I've got 684.02. All right, so let me put this here. 684.02. Okay, I know you're like, okay, 684. Don't do that. Go ahead and round. Oops. Go ahead and round up to 685. We always want to have more of a sample than we need to. So for this, we need 685 to do that. And I'm going to put this right here. We knew the P and the Q. Okay. That's how we knew that difference. So again, so for the first part of the sample, I didn't know it, so I had to use 0.5 and 0.5. But for this one, I did, so I used 0.65 and 0.35. Those are the two differences in those.